but not quite sure exactly when it is. Okay, there we go. We've got 100%. And so here we are, CET466. Just the reminder, this is being recorded, so if you don't want to be recorded, there is the YouTube live stream. And I probably should, let me just see if I can pick up the link and send the link out in the links channel. There we go. Get a shareable link. It's copied, and I will put that in. Where's it gone? I think that's the links channel there. Let's do that first. There we go. So that's me. And let me just make that a bit bigger so it fills the screen. There we go. So that's where we are. We don't have that many sessions left before Thanksgiving, and that means we don't have that many sessions left at all. Can everybody go on mute, please? I'm getting a bit of background noise there. There we go. There we go. So there we go, that's better. Now, so that's where we are. As I said, I haven't really been following this, although I did go through and check, and I think we're mostly good as far as the list of topics that I want to get through. I did want to maybe backtrack a little bit today, but we'll see what happens when we get there. Right, and the lab today is, as I talked about last week, is debugging that 4-bit adder subtractor. I apologise, I haven't had a chance to grade most of Lab 4, so please bear with me. This particular period is a little bit of a heavy grading period for me, so I'm hoping to get all the labs graded by the end of the weekend. If not, it'll be Monday morning, but I should have time. I just have all of the Fairfield students' midterms coming up, and also a lot of assessment other than the midterms from Fairfield as well. So just a reminder about what we did last week, right? We looked at really 2 or maybe 4, depending on how you look at it, statements, and both of these statements, let me just get a drawer up, right? Both of these statements, the case statement, and let's make it a little thinner maybe, there we go, and loops, and there's 3 different sorts, loop, while, and for. Both of these sorts of statements have to be inside a process, right? And the nice thing about a process is that it allows us sequential execution. Remember, if we just have statements like this, maybe there should be single quotes around that. If we just have statements like this, or even more complicated statements, then these all outside of a process, these all happen at the same time. But inside a process, we get, well, in this case, there's really only one statement, I suppose, but we get sequential execution. So if there was a statement down here at the end, then there would be the case statement would execute first, and then you'd execute this statement here. Does anybody have any questions about what we talked about last week in terms of VHDL? No? Okay, so let's proceed. So this week I want to talk about, actually, Abraham, can you mute, please? I did have you muted, but you won't be able to unmute if I mute you. Okay, let me know in the text channel. I'm going to mute. There we go. And I'll bring the text channel up. Yeah. Okay, so yeah. So what I want to talk about this week is related, and it's this stuff was two things. One of them is remember with our process statement, right, there's sometimes a label and then a colon, and then here in parentheses afterwards, it's what's called the sensitivity list, right? And what that sensitivity list is if anything, any of the signals in that sensitivity list change, then this process gets executed. Okay, and the trouble is we don't necessarily want to execute on every change, right? Remember, oftentimes we have circuits that are driven by a clock, and that's supposed to be a 50% duty cycle clock, but it's not really. And oftentimes we want things to only happen, right, on the positive going transition. Positive going transition, or the other way to say that is on the rising edge. Or sometimes we want to do things on the negative going transition, right? Or the falling edge. And the way we figure out where we are, one aspect of it anyway, is using attributes of signals, right? So you have to have a signal, but these attributes tell you more information than just the current value of the signal. So that's one piece we're going to look at today. And then the other piece is related to what we looked at last week in terms of the case statement. And this is a with select statement. And remember, one thing we could have done with the case statement is directly implement a truth table, right? And I think we did an example of that within quarters. The with select also allows us to do something similar. Okay, so we're going to look at both of those, and what I'll probably do is again do a quarter session. I think that helps. It also helps me make sure that I tell you code that actually compiles rather than making it up on the fly. So I was going to remind you about the midterm, but it looks like everybody's booked their sessions. And I think that's true. Please try and make your session. If you can't, give me a bit of a heads up if you can't make it, and we can rebook you. I'm not going to say anything more about this, but you have all of that information. Later on today, I'm going to give you some time to look at Lab 5, because I don't think we've got everybody in a group, and if you're not in a group, you're not going to be able to submit Lab 5, so you're not going to be able to get a grade for Lab 5. So that would be a bad thing. So we'll spend some time figuring that out later today. And then I think I talked about last week the debugging things like these glitches, right? And there's some glitches there as well. And maybe that's one there. It's a bit hard to see. Right, there's a few glitches there that probably shouldn't be there, and we'll look at in the lab today. We'll look at we'll figure out how to deal with those. Okay, so first of all, let's go talk about attributes, and I'm going to switch over to the VHDL nodes. And I might just bring them down the bottom here. And that's the with statement, I think. I've forgotten where. Let me just, sorry, I should have figured out where the slide deck is, but I haven't. Let me I've obviously looked at too many slides, so I'm just going to open that up. One of the problems with all this wondrous OneDrive cloud computing is that Microsoft has decided that you have to use it in everything, and it makes it harder for me to actually remember where everything is because it gives me too many options. rather it puts the OneDrive options up ahead of everything else, which is, I know where I put it on my machine, and that's where I want to get it from. Okay, so we want attributes. And where's that? That's on page 87, so that's going to be down here somewhere. Maybe it should have been before that. We did variables. Haven't done if statements. We should probably do if statements. We did case statements last time. Conditional loops we talked about. Attributes, here we go. And let's just view that in a bit more. Why did it change? It went away. That's no good. There we go. Sorry about this. I should be a bit more organized, or at least I should figure out how to pull out particular pages faster. Okay, so an attribute. Right, so the aim is we want to do something more than just get the current value of the signal, right? We might have our signal A, and we know that A is either 0 or 1. But there's lots of other things we could pull out of A, right? And one of the key pieces, so the thing that attributes of A allow us access to are the previous value and the time since the last change. And the nice thing about these attributes is it allows us, as I said in the preface, to do an edge triggered event, right? Which is often something we want to do with logic. We want to trigger on a positive going edge or a negative going edge. And the way we access the attribute is we put the signal name after the, we put the keyword, and I'll get to the keywords down here, after the signal name, and we concatenate the two with an apostrophe. So for example, a single apostrophe, or apostrophe rather, event. Okay, so that there's no spaces between them. And here are some of the attributes. There's event, transaction, last value, or last event. Right, so event says that there was a change in the signal. So to get a rising edge, we say clock quote event and clock equals 1, right? So here's our clock signal, and this is an event, and this is an event, but we want the rising edge. So after a rising edge, the value of the signal is 1. So that's the one we choose. right? If we said clock equals 0, right, then we'd get the event and we'd be on the negative going transition, or the falling edge. Okay, that's one of the attributes, and oops. Oh, that's no good. That's what's happening. I'm using both my mouse and the stylus, and for some reason they're interfering with each other. Okay, the other piece is, or another attribute we can use is transaction. And this tells us when an assignment is made, right? So if we go A is assigned to be 0 and A is assigned to be 1 and A is assigned to be 1, right? All three of these are transactions. But if A was initially a 1, say A was 1 initially, only this one and this one were events, because this one here, the value of A didn't change, so we don't have an event happening on between the second line and the third line. Okay, so the way you would use that is like this: process, and you set the sensitivity list. Instead of setting the sensitivity list just to A, you decide to set it to a transaction on A. Right? If anybody ever assigns anything to A, regardless of whether it changes the value of A, then this process will execute. Right? Then we can look at the last value. Sometimes that's useful. We can find the last event, or rather the time since the last event. Which can be useful. And the way you use this is for finding timing violations, right? If things happen too quickly, right? So here, the last event was less than half a nanosecond before the current event, right? This process has started on the current event. The last event happened less than half a nanosecond before, so that was too fast, so we set the too fast variable to be true. Otherwise, we're okay. Okay, I'm just a little confused. Let me okay. just another thing of interest in this sort of area, and what I'll do is I'll put this into the notes. So let me just take a screenshot of this, and I'll copy the URL so we know where it came from. Where are we? Screenshots. And there we go. It might be a bit big, but anyway, there's the I'll just pull that down there. So we've got the let's make the, doesn't have to be quite that big. There we go. That's all right. So there's the URL. So another useful function, if you're using std@u logic or std@logic, right? These are the IEEE library types. Is there's a function called rising edge, right? So if you have clock as your in your sensitivity list of your process, then you can use the if statement and use the function rising clock to effectively do the same thing as clock event. It should be event, not event. Let's just write a T rather than a D. It will do the same thing as clock event and clock equals 1. Okay? So sometimes, maybe rising edge is an easier way to think about what's happening rather than clock event and clock equals 1. They mean precisely the same thing. It's just one maybe is easier to read as a human than the clock event and clock equals 1. I believe there is also a falling edge variant. Let me just check to see. Yep, there we go. There's the falling edge version. And it detects going the other way. So again, if readability is important, then there we go. So there's the falling edge. And let me just, I should have taken a screenshot before I killed it. Let me take a screenshot of that one. Too, and I'll insert it in here as well. I don't want to print out, I want a picture this time, don't I? Yeah, so there's the falling edge information. Okay. Any questions about any of that? Okay. So let's do this. So that's where I want to get to later. So let me just close that though. So what's this one called? This one is called Labs Lab 4 4-bit adder. So this time I'm going to close the project and I'm going to do a new project. And we can call it, it's not going to be a lab, this one's just what I thought we might do is make a JK flip-flop in VHDL. Yes, I do want to create it. We want an empty project. Haven't got any files to add yet. I keep forgetting which one it is. I think it's the C8. EP466 C8. I think that's the one I need. And my simulation is Model Sim Altera. That's probably a good thing to do so you don't have to go in and set it up later. And there we go. So that should set up a project for me. Now I need a new file and I need a new VHDL file, and I need an entity, and I'm just going to call it, let's try that again. I'm just going to call that what it tells me. So there's a few things I usually like to start with, right? Let's just go back and have a look at our full adder, right? And the first thing is to make sure we're using the IEEE library. And then the second thing is we have an entity statement, which is not going to be the same as that. So let's just get rid of all that. I'll put that in a comment here just so we've got some reference. And then we also need an architecture. And I'm going to call this JK flip-flop. Right, and it's not a full adder, it's a JK flip-flop architecture, and it's of type JK flip-flop, and we don't need to do anything here. So I'm going to go to the bingo. And Stephen, you need to tell me something that goes in the port statement for a JK flip-flop. Do we have Stephen? You don't know the answer? Okay, thank you. So the question, really the question boils down to what are the inputs and the outputs of a JK flip-flop. So let me try someone else. And I have no idea who your is. I probably should redo the bot to use the names you're using within the classroom, because that's that might make it easier for me to figure out who's who. Any thoughts on your? Okay, let me try someone else. Nasmeen, you got a thought on what we do in the port statement of a JK flip-flop? Okay, well, let's do this. Let's go to Google. Right, and let's go JK flip-flop. And let's see what we get. Electronics tutorials, that's usually not too bad a site to go to. Right, and there's a symbol, right? So we've got 5 things coming out. We've got, or at least 5 external connections. We've got J, clock, K, Q, and Q bar. Okay, so let's have a look. Let me just I'll just put that into our OneNote notes, so we know what's happening. It's our conditional loops. I think we've got a right. So the aim was to look at so this is and we could get this out of well, just about any textbook. The Tochi textbook from 363 will have it. In fact, I probably have the notes, the slides for that. But let's just use that that page, right? So now that we have, in fact, let me just go back to here and pull that one back here. Oh, it's already there. Right, so let me call on someone else and let me know what goes into that port statement. So let's try bingo again. And I really should know who that is. AFAF? What goes into the... it's Kyle. Yeah, that's right. So Kyle, what's what can you say? Oh, really? Oh, thanks, Dan. I probably should get more into what I really want to do is see if I can pull that information out from in the bot, so it shows both the handle and the nickname. So I'm pretty sure it's probably there anyway. So Kyle, any thoughts on what goes in the? So we've got, looks like to me we've got 3 inputs. We've got J, K, clock. Right. And I'm wondering, Javier, whether I should again change the bot to do that. That might be a little annoying, but probably worthwhile doing. Okay. So no response. Let's try someone else. Carl Bechtold. Any thoughts on what goes into the port statement or the port line of an entity if we're making a JK flip-flop? Okay, I understand it's too early on a Saturday morning, so let me have a go at it, right? So we've got J, clock, K. That would be good. I should do that. So Daniel, do you have a suggestion? Okay, right, so let's go with J, K, clock, and they are inputs with stated logic. Yeah, that's right. That's I tend to if they're all the same type and they're all the same they're all inputs, then I tend to list them just as comma separated values like that, and then on the output I go Q and maybe Q bar, and these are outputs and stated logic as well. Okay, so that's the way I would do that's the way I would do the entity statement. Okay, so now we've got all that sort of stuff, and that looks pretty good. So now what do we do? Well, now we've got to actually think about what it does, right? So let's see if our see what happens here, right? So it looks like we have to do some conditional, right? Because in this case, it's looking like a there's a transition. Sorry, something's just happening there. Yeah. It looks like that things really only happen on a transition, right? So on a transition, when J is 0 and K is 1, right? And on a transition when J is 1 and K is 0, and then we get the toggle when both J and K are 1, and we get nothing happening when both J and K are 0. So how do we do that in here? Any thoughts? Let me go with bingo again, although I haven't been very Amaziah, you got any thoughts on what we have to do here? So the trick is it's related, at least part of it is related to what we just talked about before coming into quarters. So I would think about a couple of things, right? The thing that this says, right, is that, well, for a start, there's a relationship between Q and Q bar, funnily enough, right? They're complements of each other. And that's okay. But what that's telling me, I think, is that we may need an intermediate variable, right? We may need a signal, and I'm going to call the signal Q value, and I've forgotten exactly what the syntax for signal is. Let me just look that up quickly. Right, so we do signal Q value, and it's got to be its type, right? Static logic type, and I'm going to assign it to an initial value of 0. Okay? One of the things that you really want to be careful of with any circuit, but particularly with digital logic, is you want to be able to make sure you know exactly what outputs are happening whenever you start up. If you don't know what outputs are happening or what state you're in, if it's a more complicated state machine, then you could be in an undesired state, and that could be unsafe depending on what you're using the state machine for, or the output for. So in this case, I'm going to have a signal like that, and I know definitely something I want to do is that, and that. Right, let's just see if that compiles. Tells me, because that's one reason I like talking about code within an IDE, so that I don't inadvertently give you syntax errors and stuff like that. It does take a little longer perhaps, but I think it's worthwhile doing. Okay, so I've got something on line 5. What did I do wrong on line 5? I should have had a semicolon there, I think, instead of a comma. That's my bad. Let's just have a look at the full adder while that's happening. Yeah, so that should have been a semicolon going between the two different types of parameters in. Okay, that looks pretty good. So it's compiling now. Of course, it doesn't do anything, right? What I think we'll see now is we will only see that Q is 0 always, and Q bar is 1 always. So let's, should I do this? Yeah, why not? Let's try it. So I'm going to start a test bench template writer, and it looks like I got the wrong type because it's put out a VT, which means it's Verilog. So I need to go back into the settings and simulation and change Verilog to VHDL. We already have a model sim Altera. I will have to come back into here once I've got the test bench and add it in so to ensure that it compiles. But let's redo the template writer for the test bench. And now we've got a VHT file instead of a VT file. So let's just open up that VHT file. And it doesn't like me making that any smaller than it is. That's no good. Okay. So here's our VHT file, and I think all I want to do is recompile everything. Let me just go into that settings and add the test bench. Right, we've got to make a new test bench. And we'll make a new test bench and we'll call this JK flip-flop test. And we'll find the simulation that we're using. That one there, VHT. And make sure it's added. And we'll go OK. And OK. Right, so now we'll compile a VHDL test bench and run the tool model sim Altera. And I'm just going to recompile the whole thing. So we'll kick it off like that. Okay, that's compiling. We'll wait till it's finished and then I'll kick off a simulation. Okay, that's done. So let's go Tools, Run Simulation Tool, RTL Simulation. Thinking about it. It's got an error loading design again. Not quite sure what that's about. So let's just select both of those under Work and do a recompile. And there's no errors there now, so that's good. Then we can just select the test bench and go Simulate. And there's the things we're interested in. Right, and we can go Add to Wave Selected Signals. And let's just pull up the wave. Right, and I usually change that to nanoseconds rather than picoseconds because that's usually what we're interested in, and then we can simulate. Right, and so there's our simulation. It looks like maybe the initial value had been a Q of 1 and a Q bar of 0, but once we do our initializations, now Q is 0 and Q bar is 1, and it doesn't change. Okay, so now we've got to figure out how do we make it work. So, like I said, one of the key pieces is to figure out what happens with the the JK flip-flop. So we need to do something different with different values of J and K, and we only need to do it on the clock. And let's assume we're doing it this way. Remember, if there were a let me just again take a picture of this. Did I put that into OneNote? I don't know whether I did. Right, so let's just also put that picture in here so I can draw on it more than anything else. Right, so here's the picture, and remember, if this clock input looked more like this, right, if it had a bubble on there, then this is a negative going transition clock, or a falling edge clock. This one here, because there's no bubble, that means it's a rising edge or a positive going transition. Okay, so that means that tells us something about what we need to do in quarters, in our VHDL. Right, so one thing we could do is we could say, let's call it JK, our process, and let's just check that that's the right, we need to have a begin and then end process JK. And then end process JK. Right, so we need to have something like a process, and what do we need to do there? Let me go with bingo again, see if somebody's... Okay, I'm at a loss about that one as well. DK Exos. I really should learn all of these, shouldn't I? Oh well. Oh, that's you. Thanks, Anthony. You don't know? Okay, thank you. I think you're excused anyway. You gave us an answer earlier. Let me just... Oh, I see. It does do that. Okay, let me go with another bingo. Quentin, any thoughts? What goes in this?
Do you need to like set the J, like J and clock to like a NAND gate, and then K and clock to another NAND gate? It's kind of like that, setting up the logic gates.
Well, yeah, but first, what all I'm asking is, I should have go up to it. So, what I'm asking is, what goes into the sensitivity list of the process? When are we doing a change? So what signal should I put into that into the sensitivity list of this process? Okay, any thoughts? Remember we talked, we had...
I'm not too sure.
Okay, so we had a look at there we go. Right, so the main thing that's happening is we've got this, the change happens on, in this one's saying it's a negative going transition, but I think this is telling us it's a positive going transition, right? So in fact that's what this is saying, it's a positive going transition. So I think what goes in here is clock, right? Because we don't want anything to change unless there's a positive going transition. And then we can do if clock event and let's just use lowercase, and clock equals 1. And I've forgotten I think it's then, is that right? My problem is I have learnt too many languages and I forget all of the basic syntax. And it's an end if. Right, so I think that's part of what we want to do. So we're only going to do we're only going to do anything when clock changes, and we're only going to do anything after that if clock has changed in a positive going way, right? So that there was an event, a change in the value of clock, and the current value of clock is logic 1 or a high. Okay, so I like doing what is called test-driven development, right? And what that means is you try and write the code at about the same time you write the tests. And in fact, even more pointedly, you're supposed to write the test first, and the test should fail because you haven't written any code yet. And then you should once you write a test and it fails, you write the code that makes the test pass. So let's do this. We have our signals set up appropriately, and let's set J to be 0. In fact, let's put it in single quotes. Let's set K to be 0. And let's set clock to be 0. And then we're going to wait for 100 nanoseconds. Okay, and then what we're going to do is we're going to set clock to be 1. And maybe we wait for another little while just to check that happens. Now, what happens if both J and K are 0 and we do a transition, right? If both J and K are 0 and we do a transition, then nothing should change, right? It only changes potentially in one of the other 3 options with values of J and K. So what we should see is assert. In this case, we should see that Q equals Q, and I've forgotten what we had. What did we call it? We called it, what was the, the last value, last underscore value, right? So in this case, we want the value of Q to be the same as the last value, because 0 and 0 on J and K is nothing. And we're going to say the report would be Q changed when it shouldn't have. And this is J0, K0. And severity error. And we could do the same for Q bar. So why don't we do that, just in case it's possible that we have set it up that Q bar okay, let's compile that. Now the problem I have, and from a test-driven development viewpoint, is I believe this test will pass already, right? Because we don't do any changes at all. So let's compile it. Okay, that looks like it's compiled. So now I'm going to go back to my library and recompile these, and then re-simulate my test bench. Clatters around a bit, and then add to wave. Oops. I actually didn't want to do that, but that'll do. In fact, let's kill the wave and try again. So we don't want those, we just want to, we don't want the signal, the internal signal, we just want add to wave selected signals. And let's go back here, change that to nanoseconds, and let's just okay. So one thing you can see that's changed is ooh, that's interesting. Our inputs are now no longer red or undefined, right? Now that's because we've set them in the test bench. And we've still got those two. And let's just go to the... Ooh. I don't think that happened. Or maybe... Well, for a start, we did a boo-boo, right? The this should have said Q bar, right? Otherwise, so for some reason, it looks like it thinks that our last value, and I suspect the reason is because of this initialization. I think if we started out our flip-flop, I think if we started that as a 1 and recompiled that, I think we'll get we wouldn't get a test failure. So let's just try that. Wait for that to complete, and then I'll go over to Model Sim and do a recompile. Okay, that's done. Now back to my library, my work, recompile it, then simulate that. Really wish it wouldn't crash and bang so much. Okay. And then I want to add those to my wave, selected signals. So I've added those. I'll change my picoseconds to nanoseconds again. I should be able to set that default somewhere, but I haven't figured out where yet. Okay, so now let's simulate it. Right? And we've still got transitions for some reason. And let's just, go back to that one. And we've still got the 2 errors. So I'm a little concerned about that, but not too much. So what I think we've got to do is do another clock transition. Right, so let's do this.
So you do want to go until it fails?
So yeah, if you're doing I actually don't think it should be failing right now, right? And I think it's because of the initialization that things are not setting up appropriately. So all I'm trying to do is I'm just trying to check that the values are all right. So what should happen here now, I think, is we should get the last values correct. Does that answer the question? I'm not sure whether I answered the question. Is that?
You did.
Yeah? Okay. So it's coming up on break time. What I'd like to do is to get to a point where we have this test passing, and I'll do one more test, excuse me, and have that fail, then we'll break, and then I'll go back and we'll figure out how to make that test pass in the implementation of the JK flip-flop. Okay, that seemed to have worked. Let's just recompile here. And then re-simulate. Excuse me. Okay, I think that just added it without doing any clattering and banging. It looks like it did. Let's move that one over so we can see them. Change that to nanoseconds. And then let's do a... Right, so now we've got the clock toggling a couple of times. And let's see... Now... I'm going to clear that. just in case that was from before. So I'm going to restart the simulation. And let's just run it again. And we're still getting failures.
What does last value do again?
So, oh, maybe you're right. Maybe that's the problem. I think, so last value gets the last, let's read the detail, shall we? So tells us the last value of a signal before its most recent assignment. Okay, so what I think should be happening is, what I think should be happening is, right, we set it up with clocks happening, and there shouldn't be any changes to the value of the output, right? We start off with the value of 1, and we output it on our Q output, and it doesn't change. We haven't actually done anything based on the clock, so it should just always be 1. So I'm wondering whether that's the problem. I'm wondering whether because there has been no other assignment to Q, that it's getting an error, or rather it's assuming that something else had happened. So let's try something else.
Could you set Q equals 0?
Well, that's the thing. You really can't, right? Unless we did. Well, let's try starting the.
Assess it, not like set it.
Sorry.
Like assess Q at equals 0.
Well, that's the problem. You. I don't think we can. The only way we could set Q equals 0 is by setting J equals 0 and K equals 1, right? And then that should reset the value. Okay, let's do this. Let's have a 10-minute break, and when I come back, I'll hopefully have resolved it. I'm not going to go with music. Is everybody okay so far? Does anybody have any questions about what I've done so far? No? Okay. Let's take that 10-minute break, and when we come back at about 10:30, maybe a little bit after, I'll see about fixing what I've started.
I do actually have one question about the. I was gonna say, what if you said if you set J to 1, it would be 0, or vice versa, K to 1, it would turn Q to 0.
Right. So the point with J and K is that you can either, you've got one of 4 possibilities depending on the values of J and K. You can either not have Q change at all on the clock transition. You can have Q go to 0 on the clock transition. You can have Q go to 1 on the clock transition. Or you can have Q toggle on the clock transition, depending on the values of j and k that you select. Okay, and I think my problem is I can't use last event or last value for the in the test, and I just need to think through how that's working. Okay.
I was gonna say, what if you set the value to 1 and then back to 0, so it would populate an output on there, right?
Ooh. Maybe that's not a bad idea. Maybe. Let's just see if that compiles. So let's, something like that. This is in the test though, right? So, and these are signals in the test. They're not what's coming out of the JK flip-flop. Let's just see if that compiles. I don't know whether it's going to like that. That's not a bad thought though. Initializing the signals in the test. I probably should have done that before. Okay, it's letting me do it. So now let's go back to library, work, recompile everything. And we're good. Resimulate. No, we're still getting...
Yeah, worth a shot.
Worth a shot. Good idea. Okay, let's take that break, and I'll see if I can resolve it when we come back. Okay? Thank you very much. Okay, we should be back. Haven't quite figured out what's happening yet, but let's see if what I've been playing with just recently works. Probably won't, but let's just try it out. That's interesting. Right, so we're still getting those test errors. So that means I'm thinking about it the wrong way. One thing I thought I could do is maybe, oh, that's probably not the right thing to do. So the standard value of Q is 1 based on our JK flip-flop, right? And I thought that if I just set that there, so I moved this initialization stuff into the init process. It used to be down here in the always process. But what I didn't do is I didn't change those initializations to match the initialization here. So I'm wondering, let's just not do that and not do that and see if that compiles and see if that gives us an error or a So we haven't got very far with our implementation of the JK flip-flop, but I think this is a useful dig at how to interact between your VHDL file and your test bench. Okay, so we're all done. I think this is probably going to do the right thing. We've set our J, our K to 0, and then the reason I was now setting the clock to 0 up here is I was thinking that now what we could do here is that, right? So every time rather than having to keep track of what the clock is, we can just say clock is not clock. Okay, so we can just toggle the clock one way or the other. And now I think we've got all of our Q values aligned. Our initial Q is 1. Our initial Q bar is 0 in the test bench. In the VHDL code, our initial Q is 1, and I think that means our initial Q bar is 0. Okay, let's see if that compiles. Thinking about it. Not quite done yet. Okay, we're done. I just do like to go over here onto the library and recompile everything just in case, and then simulate the test bench. Mainly so we clear the previous simulation, so we don't get confused by which simulation we're looking at. And then add to wave selected signals. And that should have added them. And I'll just move that over here so we can see the names of the signals. And let's just check that there's no output there. There's no output there. Let's hit a run once. And we don't have any output. Let's hit a run again. Now we've got a clock. Oh, we did get errors at 400 nanoseconds. So I'm still not doing the right thing. The other worrying thing for me is the clock has now gone don't care, right? It's gone red. So I think that means, where's it gone? I think that means that setting the clock here is probably a bad thing. So I think just leaving it set to 0 there initially is probably enough. Let's just see if that error, that is the clock going to undefined, or rather don't care, I think is the X, is resolved by removing that clock setting to 0 in the init process. And let's just check that init process as well, right? This init process will always execute because there's no sensitivity list. But when it executes the first time, it'll wait after setting J and K to 0. Okay, so that's that done. Now we can come back here. I apologize if this is a bit repetitive. Unfortunately, I think this is pretty much par for the course. And again, particularly if you're learning this stuff, right? Admittedly, I've learnt this stuff before, but as I mentioned earlier, the details are a little sometimes a bit beyond me, which is why I like to use a compiler to tell me that I'm doing the right thing. Okay, so there's that. Right, and at least now our clock is nice and happy and green, but we're still getting errors. So let's think about how to not get those errors. So one way we could not get those errors is we could say, okay, the first thing we're going to test is that Q, we know Q has the right value or right default value. Okay, and the right default value should be 1 for Q. So let's test that instead. Right, so we're testing that Q is 1, and that means we're testing that Q bar is 0. And let's just do this. Let's say Q is not its expected initial value. It's nice to have the tests match what you're actually, the output of the tests matching what you're really looking at. So let's try that. maybe that's where I should have started anyway, right? Checking that everything is in the right initial condition. And I think part of the issue is we're not actually setting anything in Q and Q bar yet. So I think it might, the last value might not actually have a last value. So that might be why it's problematic. Okay, let's try this again. We'll recompile. We'll simulate. Okay, that simulated. Oops, I need to go back here and do my addition. Okay, that's all good. And we don't have any errors. So it is actually testing something that maybe is a little trite, but it's testing at least that the initial condition is correct. So let's do the next thing, and let's check that let's do the next test, right? So the next test will be test for toggle. Right, so let's do that test. So that's the clock change that we want, but to get a toggle, remember we need to set J to be 1 and K to be 1, right? And then we need to check the values of Q and Q bar, and I probably want to do those weights after the clock, right? Not before the clock. Okay, and in this case, now we should expect that. So Q did not toggle 1 to 0. And then this one is Q bar did not toggle 0 to 1. And we can do that twice, right? Because just because it toggles one way doesn't necessarily mean that it toggles the other way. So let's try and toggle it again. And now Q did not toggle from 0 to 1 back to 1, and Q bar did not toggle from 1 to 0. So let's see how that goes. Okay, we've got to compile. Let's just recompile here just to be sure. Simulate it. And I'm just going to say, don't ask this question again. Oops. Now we have a problem. And I think I know what the problem is. And it's to do with my test bench. Right, the problem is this. I shouldn't have done anything in there. Right, this is saying always set j and k to 0. And then down here, we're setting j and k to 1. And that means it's not going to be able to do the right thing. So I need to not do that. And maybe a better suggestion would be up here to set the right values here. And then I think we should be able to, I think that should be a better way to do it. So there's a few reasons why that simulation will give a red trace. One reason is if the value is unassigned, and in that case, if the value is unassigned, it should be I think it should be an X here, but it'll be a U here. And sometimes if there's a conflict between what the value is based on outputs from units under test and what the test bench assigns the value to be, then it'll give you an X. So you should never get red traces here. If you do, you need to debug why you're getting red traces. Okay, so that compiled yet again. Let's go back here, recompile. Thinking about it. Okay, oops. Okay, let's try that again. Let's simulate it. Add those to our wave. Go to the wave so we can see the signals. Right, so we've got a few more toggles, and we change the value of j and k from 0 in the first instance to 1 in the second part of the test. And now at time 600 nanoseconds, we've got a did not toggle. Okay, so now let's see if we can get rid of that error. The way we get rid of that error is somewhere in here we could do either a case statement or an if statement. Because we haven't done much with ifs, let's use an if statement. So if j equals 1 and k equals 1, then end if. So what do we want to do in that case? Then we want the Q value to toggle, right? So Q value is equal to not Q value. And I think that's what we want to do in that instance. Let's just check. See if that actually compiles. I don't know whether is that the right assignment statement for signals. I wonder if I should have done colon equals instead. Yeah, I should have done. Oh, no, that looked alright. I just forgot a semicolon at the end of the if statement. Let's see if that's okay. So there's nothing stopping you from doing exactly what I'm doing while I'm doing it, and I'm hoping some of you are, right? Because getting to know how to use the tools is part of what I want you to get out of this course. That's why I've asked you to install them, or at least have access to them on the Citrix server. Okay, that looks like it's all green. Really does crash and bang a lot, doesn't it? I think it's written in Qt, and that's probably why. Qt is a cross-platform UI tool. Okay, let's run that. Okay, so now not only do we have J and K changing, we've also got Q and Q bar changing. And look, no errors reported. Okay, so we've done the first bit of implementing a JK flip-flop. We've got the toggle operation working. So now let's go back to our test. So this is testing the toggle. And let's just go back to our JK flip-flop. And what's the other one? We want to reset, right? So J is 0 and K is 1. So let's do that as the next test. J is 0 and K is 1. Right, we'll do that. And then we'll just cut and paste part of our test anyway. Now, so we're wanting, this is setting this is resetting, right? Or Q bar setting to 1. Now the problem is, let's just go back to our simulation, right? Our 1 at the end of the last test, our Q output was 1. So that should be okay. But let's do this. Let's check the other operation as well. So if we're okay with this toggling, let's sorry, I should have. Let's grab that and let's toggle. Right, we set J as 1, K as 1, we'll toggle, and then we'll redo the test, right? Because if we had it, this test will pass or fail depending on the previous value of Q, and it's a bit hard to determine what the previous value of Q was. So let's make the test check both possibilities, that Q was 1 to start with or Q was 0 to start with. And if we're okay that the toggle happened, and we tested the toggle first, right, then we should be okay if we test. Okay, so now we've got both of those happening. So let's recompile that and resimulate, and let's see if we get a test failure now. Actually, let me just check that I did that right. Yeah, so this is setting Q to 0. So we check that Q is 0. Sorry, I see there's a... thanks, Dan. I didn't see the message until way too late. Okay, that's all right. Okay, so I'm going to ask the class a question soon, and the question's going to be, what do we do next? But let me just see if we can get this. Let's just reload it. No. Let's try that again. Sorry about that. Recompile. That all looks good. Simulate. Okay, we're all good there. And let's just make that nanoseconds. Right, so I did lots of toggling. We had the clock going. And at least one of our tests for reset failed. So Eddie, what do we do to fix it? How do we make the test pass? Any ideas? Okay, let's try someone else. Okay, Eddie's typing. Let's just wait for Eddie to type an answer, maybe. Feel free to use voice. Okay, nothing from Eddie. Saibor. I'm not sure who Saibor is. That's Jordan. Hey, Jordan, what's up? You got a thought about what's next? No? My bingo game is not. Okay, how about Yasmin? Yasmin, you've got a thought about what's next?
I'm not sure. I'd have to take a look at the code to figure out what was wrong.
Well, so let's go back to the code, right? So this is all the code we've got so far, and it only currently deals with j equals 1 and k equals 1. So what should we do next for doing the reset?
Well, we should deal with if j is equal to 0 and k is equal to 0. Or no, actually, set is j is equal to 1 and k is equal to 1.
Hold it. Let's see what the reset is. It's j equals 0 and k equals 1, right?
So I was right the first.
Yep, that's okay. Right, so what I'm going to do, is copy that and paste it. So the next one is j equals 0 and k equals 1. And then what do we do here? We're not going to toggle it. What do we do here?
Set it to 1.
Well, we want to reset, so we want to set it to 0. Okay? So, right, so that's the next one. Let's recompile that and see what happens. Hopefully it'll compile. Okay, there we go. Just about there. There it is. Flip back over into Model Sim, recompile, run the simulation again. And I'm just going to make that, I don't know, 2000 nanoseconds, so you just have to hit it once. And there we go, we've got various things happening. Let's see what the test output said. The test output said nothing, which is good, right? That means we now have the toggle and the reset options on a JK flip-flop working. So what do we do next? Let's go with bingo again. Abraham, would you, let me just unmute you maybe. There we go. Do you have a suggestion about what we do? Okay. Let's try someone else. Pro Daniel.
It's me.
I guessed.
J equals 1, K equals 0, and then we set Q value to 1.
Yeah, exactly. Right, so we can do that. And that, so I can see my keyboard. Okay, that's what we could do. Maybe, again, going with the spirit of test-driven development, maybe what we wanted to do was write the test first, right? That's okay. Just so long as we get a working system, it doesn't really matter that much. So now this one would be the set option, right? So we wanted that to happen, and we want Q to be 1 and Q bar to be 0. So we want Q to be set and Q bar to be reset. Then we do another toggle just to make sure we've got the right thing happening in both possible cases. And we want to assert that so we want the set option. J is 1 and K is 0. Did I not do that properly before? There's reset. That's alright. Let's just see if I can see more of the screen. There's set. Right? And if this is a set, then we want that to be 1 and that to be 0. Okay, so that's the set, and that's our test for set. Okay, let's see if that compiles. Okay, that's pretty much compiled. Go back to library work, recompile, simulate the test bench. And there we go. Add those to the wave. Make that 2000 nanoseconds again. right? And let's see what happened there. And again, we ran it. It looks like we ran it to the end because, oh, maybe we need to run it again. Let's just try running it again. Yeah, it looks like we ran it long enough. There's no changes after a while. And there's still no error output, so we're still pretty good. So, last one, what do we do now? Javier, what do we do now?
Do you mind if I see the code again? I forgot. I'm sorry.
That's okay. So there's the flip-flop itself code. If you want to see the test bench, let me know.
I'm sorry, I don't know. Is it just finishing up the test?
Right, so in this case, it's the unit under test is simple enough that we want to test every possibility, right? And I think at the moment, right, we've tested J1, K1, we've tested J0, K1, we've tested J1, K0. The option we haven't tested is
0, 0.
0, 0, exactly. So let's see if that let's see if we can test that option. And remember, that option is nothing happening, right? Okay, so we do that. Now the question is that going to, how do we test that?
How do you test 0, 0?
Yeah, well, how do you test if nothing changed? And I think what we need to do is we may need a variable, right? So variable
Could this one work with the last variable, last value now, since all the values have been changing multiple times?
I'm not sure, because I'm not sure where that's coming from. I'm not sure whether the last value, I suppose it's set in the assignment. So let's try it. I was going to suggest we do a temporary variable, but let's try the last value, right? So we set that to 0, 0, and the trouble is, if we have it 0, 0, let's have a look at our flip-flop, right? If we have 0, 0, we don't actually do an assignment, right?
Okay, I see what you're saying.
So I'm not sure that the last value will actually be the right thing, right? It might just remember the last time it changed rather than, so maybe what we need to do is actually, I don't know, set Q value inside another if statement to make that test work. But I'd rather not do that. I'd rather have minimal code here. So let's try and do it the way I was starting to do it, right? And let's have a temporary variable, right? Qtemp, and what's the definition? It's just std logic. I think that's right. And then we'll assign it to a value of 0. Right, so now we've got a temporary variable. And now what we can do is we can say qtemp, oops, I think we want that version, is equal to q. Right? So now we've got, we store the value of Q. We do a JK0, we clock things. And then we compare Q afterwards with the value that we stored.
You don't need one for Q bar.
We could probably do one for Q bar as well, just to be, to be sure. And let's just know what's happening, maybe, I don't know. And then here we'd go Q bar temp equals Q bar, and then Q bar equals Q bar temp, and Q changed when it shouldn't have, and then oops, and then Q bar changed when it shouldn't have. Okay, so let's see if that compiles. Okay, that's recompiled. Let's re-recompile it, simulate it, add those signals to the simulation eventually. Okay, we've got lots of stuff happening there and no errors. Let's just check we settled down, so we've done the simulation for long enough. So we now, looks like we have a JK flip-flop. So let's do a quick context switch and go back to the notes, because there's another thing that I want to look at, wherever OneNote got to. There we go. Right, so we've talked about attributes, and the other thing I wanted to talk about today, which we haven't done yet, is with expressions, right? So concurrent signal assignments. Let's go back to our VHDL notes, and I think this is a bit further up here, but I could be wrong. Case statements, if then. We haven't explicitly looked at if then statements, but we just used lots of them, so you should be okay with if then statements. That's let me just go back and see if I can find the with statements. It's before the test benches. sorry. Oop, that was it. So it's on about page 52. So I think that means it's up here a little bit. $52 out of, I think it's 80, 95, something like that. 95, yeah. So it's a bit over halfway. Here we go. Right, so this is very similar. This select, or with select statement is very similar to the case statement we looked at last week. It's just got a slightly different flavor to it, right? So the example, right, is it's just a quick way of being able to implement a truth table. Right, and so it's like a big, let me get a pen up here maybe. It's like a big, it's like just implementing the truth table directly. So what I want you to think about is can we rewrite this JK flip-flop but now using a with select statement. Okay, so I'm gonna give you a bit of time, maybe not 10 minutes. Let's go with a 5-minute timer, and I want you to have a think about how you would implement. And let me do this. I'm going to take that code.
Is the with only used outside of a process, or is it used in a process?
That's a good question. Let's I believe it can be used outside, right? Right, so here's again another link. This one is doing the select version, or the with select version, right? With A, select B is some value, right? And when A is 0, 0, B is 1, 0, 0, 0. And there's no process around this with select. But in the case statement, there is a process around it. Okay, so I think that means we don't
What
need...
I meant by that was, can it be used within a process or not? Because I need the process around it, so I wasn't sure if it can be used in a process.
Oh, whether it can be? That's a good question. I don't know. Let's try it out, shall we? I'm just going to leave that there. So what's the syntax? Let's set Q value to be equal to well, so with, let's do it this way. With J concatenated with B, select Q value is, I think that's the right, I think I can do a concatenation to get A, and then the values I want are so we want, let me just fill in the when values first, right? So when 0, 0, comma, when 0, 1, comma, when 1, 0, comma, when 1, 1. And then I think we could just do a semicolon at the end there. I think that's the terminator, yep. And let's just do this. I'm just going to set Q value to 0 all the time and see if that compiles. I suspect you can use it outside of process, but I don't know the answer, Yasmin, whether it can be used inside. Let's see if the compilation happens. See, the nice thing about not putting it inside it looks like it doesn't like it. But let's see what the error was first before we near text width end.
You didn't end it.
I didn't end it? Oh, is that the problem? What do you mean I didn't end it? I've got a semicolon. I've got the Q value being set. Near text width. Expecting end. Oh, maybe that's the problem. It's expecting the end process before it does that. Let's just take that code and put it outside the process. I suspect this will generate an error, but it'll be a different error. So I think what this is saying is you have to use the with select outside of a process. So it's happening instantaneously along with everything else. Now the problem with this is, oh no, can't determine if operator. Oh, it doesn't like concatenation because it can't figure out what the value is. Oh, that's no good. So I think the way we got around that before was to have a signal temp std logic vector 1 down to 0, right? And then we can do temp, oops, is J concatenated with K, and then we do temp. Now the problem with this is I don't know whether this is all going to happen together, right? It's all happening in parallel, so I'm not sure that's going to quite work. But let's see. Can't resolve. Oh, okay. Yeah. So that was the other error that I was expecting, right? Now we're setting Q value in two different places. So I think I need to comment out this part of the code. Otherwise, it's trying to set It's trying to set Q value in two different places, as part of the process and outside the process. So I'm just going to comment out that process and try it again. Okay, so that looks happier. Oops, I didn't want that. I wanted that, but I wanted that. Okay, so what I want you to think about, I'm going to put a 5-minute timer on. Let's make it a 10-minute timer. I want you to think about whether we can use this way of doing things to implement the same as the if-then statements. What I'm going to do is I'm going to take all of that code and I'm going to put it into the Discord chat. Right, let's just put it under, I'll put it in under materials. Right, so you've got some code there to have a look at in materials. And what I want you to think about, let's, again, we're going to take a 10-minute hiatus, but I want you to think while you're having it, how to turn this into, maybe able to turn it into a JK flip-flop. Everybody understand the question?
Well, I just don't understand that if it can't be used in a process, how would you make it only change Q when the clock is a negative going transition or a positive going transition, depending on whichever you choose?
And that is the question I want you to think about. Okay? That is a very, very good question, and that's what I want you to think about. Okay? So, like I said, let's go with a 10-minute timer again, and have a think about that, and I will. Let's have a look at it once we get back. Okay, we're just about ready to come back. Okay, let's go to the bingo again. X Tai Chu. Any thoughts on whether we can do what I'm suggesting? Let's just bring the chorus back. Alright, so remember the question was, can we use this with select structure that takes place outside of a process to implement our JK flip-flop? No?
Wait, I'm sorry. I was in the bathroom.
That's okay. We don't need to know. So
Wow.
so the question is, can we use this with select structure outside, which has to happen outside of a process statement, so it's happening instantaneously? Can we use it to implement a JK flip-flop? Like we did in the commented out code up here. This, where have we got to? This code here. That's the thing that we think works. So let me ask this. Go ahead.
I was gonna say I say no, but I don't know why.
Okay, so the thing that may be problematic in this is we only want to do this on a clock event. Right, so the thing we may have problems with is triggering this on a clock event. So yes, change the actual Q value in the process. Ooh, there's a good idea. Thanks, Yasmin. Javier, could you change the with statement to reflect the condition? Well, that was where I was thinking of going too, but I think both of those might be worthwhile pursuing. What Yasmin says is to not change the Q value and except inside a process. And Javier is suggesting that we change the with statement somehow to reflect what we're trying to do. Okay, so I wonder if we can do either of those. So let's take Yasmin's approach first, right? So we've got well, one thing is we don't want the Q value to always be 0, right? So for a 0, 0, I think we just want Q value to be the same value. For 0, 1, I've forgotten. Let's go back to our, for 0, 1, that's reset. So that's a 0, that's correct. 1, 0 is a 1. And this one is going to be, right, toggle. Okay, so that could do the right thing. The difference is this is going to happen asynchronously, right? There's no dependence at all on the clock. And I'm wondering whether that's something our test doesn't take account of. So let's see if our test passes with that implementation, right? And the problem with this implementation as it is now is we haven't done a JK flip-flop that is a rising edge, is triggered on a rising edge or a positive going transition. So let's compile it. That compiles. Then we can come back here. We can do our recompile. And we can simulate. We can add our signals. Okay. Let me just. I'll get there, Yasmin. Thanks for that. I will see about those. I think I've added that. I just need to. Yeah, I've added those. Let's just see if this. I'm just interested to see whether this test passes already, even though we've got. Let's make it 5,000. Okay, so let's just. That's the full test. And look, our test is actually passing, even though we don't have a. So I think that's telling us there's something wrong with our test, or there's something we've forgotten in our test.
You're not testing it with the clock. You're not testing it with the negative going transition.
Right, right. So what we should do, possibly, let's just try one thing. Where's the toggle? There's the toggle. Right, so I'm wondering whether we should do. How do we test? How do we add a test that?
This is a process, right? So could you do the attribute event?
Oh, yeah. So how would we do that? How would we?
So within the assert, you could have a conditional for if there was an event with the clock event.
On the clock. Well, we've effectively done the clock there, right? So we know the clock has changed. So I don't know whether that would help us. What we might need to do is go back and check what our clock starts off as. Our clock starts off as 0, right? And then it's going to 1, 0, 1. And yeah, I'm wondering whether it mightn't be a bad idea to explicitly set the clock rather than just toggle it. That way we could tell when there's a positive going transition and when there's a negative going transition. So let's have a look. Here's the toggle. So rather than do this, we want it, let's set the clock to 1, to 0, right? So we want to, and let's do this twice. Let's make sure we have a positive going transition. Right, so there's definitely a positive going transition. And we check to see that the toggle happened, and that's okay. Right, so that's a positive going transition. Now let's try...
You don't change JK. You only change JK when you're expecting it to toggle, so that's probably why.
Right, so what I'm trying to do now is to check whether a negative going transition toggles it. Right, so now we want to check so that one should have toggled there. Because that's the positive going transition. And this one, we want to make sure it doesn't toggle. So we want to assert the same thing, is that right? Right, so if this one fails, then that would mean that it did toggle. And that's on a negative going transition. Does that make sense, Yasmin?
Well, you're testing for it to the values that you would expect if it toggled.
Okay.
The Q equal to 0 and then the Q bar is equal to 1.
Right.
So that would only be false if it.
Right, but we've
toggled.
we've done the positive going transition here, and that's testing that we get the toggle, and then we do a negative going transition, and we again test to see if this...
Well, I mean, you're testing for the positive going transition first, which should have toggled already.
Right.
Now you're not getting it to toggle anymore.
Right. So what should this test be? Should this so the value of Q shouldn't have changed, right?
Right.
So we're not changing the value of Q. So I think that's okay. The issue I'm trying to get at...
I got it.
You got it? Yeah? So the issue is that on our current implementation, I think this will fail because our current implementation takes no account of the... And I haven't used Yasmin's implementation, which I think is a fix, but it hasn't done... I think this version of the test, now that we have we're testing to see that it's a JK flip-flop that only works on positive going clock transition, so it's a synchronous JK flip-flop, at least in one condition. Okay, I think that's I think this will fail with our current implementation, because our current implementation is just asynchronous. It's not taking account of the clock at all. Okay, so that compiled. Let's go back here and let's recompile that and then simulate. And I've finally run out of coffee, so let's add that. Okay, that's added. Now we can have a look at this, and let's make that 5,000 nanoseconds and run it. And zoom, we finished it. Let's see what the... Oh, it still hasn't given us an error. That's interesting. Okay, I'm a little perplexed that it's not giving us an error, so I need to think about that. But let's take what Yasmin put in the discussion, and let's have a look at what that's doing. Right, so this is the piece that Yasmin thinks is the right thing to do, and I agree with her. Right, we've got a process that has a sensitivity list of just the clock, and when the clock has an event and the clock value is 1, so we've got a positive going transition, then we set the Q and Q bar values. Okay, so let's see that compiles. Sometimes when I cut and paste from one machine to this VNC client, it seems to put in some bizarre characters. So I just got to check that everything compiles, but it looked okay. Okay, recompile, simulate, Yep, then that all seems to, all the tests still pass, but I do think now with Yasmin's addition that we will get synchronous behavior, right? Because we're not connecting up the temporary value Q underscore value to Q or Q bar unless there is an event. So I still think there's a problem with this. And the problem is that it's going to change the value of Q value regardless of the clock. So if, for example, Q value, J and K went to 1, 0 and then back to 0, 0 without any clock happening in between times, then Q value would be set to 1, right? Whereas if we were really triggered on the clock, that change in, or that setting of the value wouldn't happen. Okay, so I don't think this is quite right either. I think our initial implementation might be the simplest, or rather a little simpler. Maybe it's a little verbose. It may be better because we're not actually, in this implementation, we're not actually changing the value of Q value until there is a positive going clock transition. Okay. So that was a little detailed, right? All I'm doing with a lot of these for the rest of the lectures mostly is going through these VHDL slides, right? Now, I'm not sure why that is showing up there, but anyway. And the only thing I wanted to show today, the new VHDL, were attributes and this with select statement. I also wanted to get you to think about a JK flip-flop and how that happened. I think I'm going to have to do that a bit more, and I'll do that a bit more next week in next week's lecture. I'm going to choose another simple device, maybe a T flip-flop or a D flip-flop, or maybe a counter, and I'm going to get you to in class have a look at how to do that in VHDL. Okay, any questions about either attributes or the with select? I do need to come back at the attributes to show you how that last value really works, because that was a little confusing, I must admit. I find it confusing, so I'm assuming you found it confusing. Not that the idea of last value is pretty straightforward, but it just doesn't seem to be working the way I would expect. So, if there are no questions about that, I did want to talk about labs, and like I said, I apologize for not having graded the lab 4 yet. If you haven't done lab 4, get it in as soon as you can. But I did want to check on lab groups, right? I think I have 3, 6, 10, 15, 20. So that means that 7 people don't have a lab group. So I think, did we set up, Celine, did we set up a lab group with you? I can't remember. I'm not going to put everybody's grades on the screen, so let me just take that back. Right, so let me just have a look at all of that. So Abraham, Zachariah, Amaziah, Evo, Edward, Nibesh, and Matthew don't seem to have groups yet. So that looks like there's Evo and Matt. It looks like I can try and get you two boards, and that means I think that'll be enough if I 1, 2, 3, 4, 5, 6, 7. We might need another person with a board. So how do we do this? How do we get people? Because the reason I'm asking is you won't be able to do the group lab assignments unless you're in a group with somebody with a board. Okay. And I'm happy to travel to get you a board, but you need to have had Quartus, Model Sim, and the device support installed on your computer. So you need a Windows machine. And I think Matt had already indicated that he has it, and Evo has also indicated that he has it. Okay, so Celine, you're... Yeah, I wasn't sure. Sorry, I was just looking up the lab groups, and that I see you are in a lab group. Okay, I'm not getting any response from Abraham, Zachariah, Amaziah, Evo, Edward, Nibesh, and Matthew. So those people need to let me know. You'll get a board? Okay. I'm going to be excruciatingly busy this week, so if we can organise it at some point, that would be good. And Zachariah doesn't have Windows. That's okay. I expect that's the case for a lot of people, or some people anyway. But the issue is, Zachariah, are you okay with being in a group with Matt? Maybe. Is that okay? Matt, are you okay with that? Okay, so let me remember. This is it's not as if you have to get together. It's the aim is that Matt will, if he gets the board, will be able to run the lab, and it's just Zach will have to be involved in that remotely, or at least via the internet. Evo, did you have are you okay with picking up a board too? That would be good, because you're another one who's indicated that. Okay, thanks, Evo. So let me let's try and get those out as soon as possible. I'm okay with delaying. So let me do the groups. Okay, so let's go with group 6, and let's do what order is that in? Let's do it by last name. So there's Matt, and Okay, thanks. And let's get Zach in there. I think Zach's on the other page. Let's go with doing it that way. There we go. Okay, so there's Matt and Zachariah. I might have to add somebody else as well. That's lab group 6, and Evo, I'll put you in lab 7. And let's see. Yeah, so I don't know, maybe I am going to need one more person, or at least I may need to make a few more groups of 3. So Evo, I'm just going to, I can't see who's in a group without showing everybody's grade, so I'm not going to do that. So we've got still got to get a group with Nibesh, Abraham, Edward, Amaziah. So I'm wondering who we can put people with. Let's just have a look at the lab groups again. So we've still got 1, 2, 3, 4, 5, 6. So we've got plenty of lab groups now. So we don't need to populate groups 8 and 9. So let's see who we can get. So Evo, would you be okay with having Nibesh and Abraham? Sorry, let's just check. Okay, so Evo, are you okay with Nibesh and Abraham? So there's Abraham, and where's Nibesh? Oh. Any group for you as well, Eddie? Okay. There's Nibesh. The S's are on the other page. Okay, so we've got that's a little better. Let's see who we've got left. So we've got Edward and Amaziah. So let's see what David and Jacob, would you mind having Edward join you?
Sure.
Yeah, okay. Or perhaps Eddie's better. Sorry, Eddie. There we go. Okay, and then let's see about lab 11. So Kyle and Anthony, would you mind, there we go, having Amaziah Gadsden join you? Is that all right? I defer to Kyle. O great and mighty leader, Kyle. Is that okay? Yeah, I think I gave the board to Kyle. Okay. I'll go with happy to revert if there's a problem, but I think we're okay. So Amaziah, there we go. Let me just refresh my page. And okay, we have now everybody in a group. Thank you for that. Few more groups of 3 than I wanted, but that's okay. That gives me a couple of spare boards. I will be in touch with Evo and Matt afterwards just to try and organise a time and a place to pick up the boards. Like I said, I'm pretty busy this week, so that might be problematic. We don't have much time for the lab I intended to do, so I'm going to push 2 things. I'm going to push the due date for lab 5, which is the first group project. I think it's lab 5. Let's just check. Yeah, so lab 5 is the first group project. I'm going to push the due date out just so that everybody has a chance to have a board and do it. Right, so when did I say it was due? Due the 17th? Let's just push it out for a week, so that's 2 weeks from today. That should be plenty of time. That gives you a chance to coordinate. It gives me a chance to get the boards to the 2 new groups, and it gets everybody a chance to. In fact, let me just check that I didn't turn it off on the 17th still. Yes, I turned it off on the 17th. So let's make it available until the 17th. Okay, so that's that one. The lab I was going to start today, that I'm not going to have time much to do, is the test bench that we made using the loop counter, right? And let me just go back to, yeah, we'll move it to the lab that I was intending to do today. We'll move to next class, right? And also next class I'm going to have much more lab time, because I do want to make sure that everybody is happy with lab 5, so that you've got a week to write it up and get it in. And then I'll kick off lab 6 as well, and I haven't changed the due date for lab 6, but I'll do that as well to make it due after lab 5. So I just did want to introduce the problem with that lab 6 looks at, that I talked about, I think, last time. Not quite sure why that green stuff is still there. It gets there sometimes. Right, so the issue, and let's just go here. And I wonder if that will let me erase that version. It doesn't actually let me erase it. I think there's a bug in the software, right? So the issue of these glitches, right? Those glitches shouldn't be there. And I think they happen a lot, but they mostly happen on the on this line here. They definitely happen a lot on the S out bit 1, right? The second least significant bit of S out. And let's have a look at why that might be. Right, so this is the one that's getting glitches. And let's see what the problem is. Right, so we get our, in fact, let's just have a look at what the carry in was. Or the carry is the carry in. Where's carry in gone? It doesn't look like it's there for some reason. Oh, the subtract, that's what it is. So the subtract is 0. So that's okay. So we've got a value of 0 on the subtract. Right, remember we changed the name to subtract. Right, so if we've got 0 on the inputs of all of our exclusive OR gates, then that just means if B naught is a 1, the output is a 1. So that's just a straight through. But what we get is there's a propagation delay there. And remember, again, let's go back to our trace. Which one is changing? Right, this is our A in. Our A in 0 is the thing that's changing the fastest. Oops. So our A in 0, this one here, is the one that's changing the fastest. And B0 changes very slowly by comparison, right? So B0, right, is that one, and it only changes over here. But let's see how if we can figure out what's happening with S1. There's also going to be a propagation delay here. And then I can't tell what it is, but there's also some other propagation delay. Let's call it TP prime. Or let's call it TP full adder, right? There's also a propagation delay here. So let's have a look at what happens in the full adder, right? And the propagation delay I'm interested in is from C in to C out. So, right, there is a going from here to here, and I'm going to assume all of these devices have the same propagation delay. Oh, very good. That looks like it's multi-sim. Oh, there we go. Oh, so you've gone through and counted them. Oh, very good. So let me just steal your see if I can pull that over to here. Might not quite come out as nicely, but let's see if it's going to be under downloads. Right, so here's an implementation in multisim, and it looks like there's up to 4, is that right? A delay of 4 between the input and the output. So here's our K, here's our C in, and there's 1 gate, 2 gates, 3 gates as far as here is concerned. But then to get to here, we get 3 gates, and we get 4, right? 4 gate delays. So let's see if we can see that here. We've got 1 there. Let me get my drawing stick happening. There we go. We get 1 here, right? So the output here, not including the exclusive OR that we may have on the to do the complement, that's going to be a 2 propagation delays. And then this one, we have 1 already here, 0 here, so the maximum delay here is 2, and the maximum delay here is 3. Here we've got 0 delay so far, without just on the circuit on the screen. We've got 1, and the maximum delay between these two is 3. So after 1, so the output here, the propagation delay is 3, but then taking into account, right? So taking into account this one, so this is going to be 3 TP if all of the gates have the same propagation delay, right? So that's what's happening. That's why there's a glitch, because things are delayed coming through. And in fact, right, coming through here, there's another TP-FA, and through here there's another TP-FA, and through here there's another TP-FA. So that's 3, 6, 9, 12. So the C out might have at least 12 propagation delays, depending on whether this also adds to it. It could be up to 13 propagation delays between input and C out.
Wouldn't the full adder from 1 get counted at the additional propagation delay in the carryout?
The full adder from 1, so which one is that? That's this one here, or 0?
Yeah, and wouldn't the carryout carry out the propagation delay from B?
Sorry, I'm not understanding.
I think I got it confused.
Yeah, so right, there's less of a delay here on between A3, B3 and C out, but the output here also depends on C2, which also potentially depends on C1, which also potentially depends on C out. This number, this total propagation delay is not happening every time, right? Because sometimes these earlier changes don't affect the value of the output, right? That's why we don't see a glitch on every transition. If we saw a glitch on every transition, that'd be horrendous. So, what do we do about it?
Can you make wait statements within the process?
That's usually what you've got to do. And where would you put those wait statements?
The connecting adders.
Right, we could equalize everything, right? So, well, where would you put it though? If we put a wait statement on, let me just change the color. If we put a wait statement between here, that's just going to increase the propagation delay. Okay? So, something to think about for next week. There's a few possible ways to solve this problem. One way is this system as we've done it is asynchronous. And asynchronous systems are usually more prone to glitches. So a way to try and address it is to turn this into a synchronous system and control the outputs synchronously. That would be one way. Another way we could think about solving this problem is there is a thing called a look ahead, right? And rather than waiting for these carry intermediate results to be generated, and they're the ones where our big delays are happening, right? Rather than waiting for those to happen using the outputs of the full adders, what we can do is we can add a little bit of extra circuitry and calculate C0 directly. Maybe we don't need to calculate C0 directly, but we can calculate C1 directly, and we can calculate C2 directly, and maybe even calculate C out directly, rather than waiting for those intermediate values to come in. And that's usually called a look ahead. But the prime aim is to do something about the differences in propagation delays. And that's a third potential. Somebody mentioned earlier about putting a weight in there. That's also something you can do, but you need to figure out the right place to put the weight, to figure out how to align things appropriately. Okay? So that's about all I have for today. I'm not going to talk too much next week about new VHDL stuff. There's not a lot of new VHDL stuff we need to talk about. I think most of it, I'll have to flip through the slides again, the VHDL slides, but I think we've talked about most of it either directly or indirectly. So I think we're good to go. most of what we have to do, let me just go back to the start slides. Most of what I want to get done from here on in is slightly increasing complexities of VHDL quarters projects, right? Increasing complexity in terms of what the project does, but also increasing complexity in making sure that it happens on the FPGA board. Any questions?
For the group assignments, how do you want us to do it? So do we each do our own code and then whoever has the board runs everyone's code, or?
I would like you to each do your own code, but to write up in a single lab report, right? So
Okay.
that will mean including the VHDL code 3 times if you've got 3 people in the group, or 2 times if you've got 2 people in the group.
Okay.
And the nice thing about doing it that way is maybe you'll all do the same way, but I'm hoping sometimes people will do the things a little differently. And getting having a small discussion if there's a difference in your implementations
Okay.
as part of the lab report. Okay?
All right. Thank you.
You're welcome. Okay, if there's nothing else, Quentin, thank you for that those pictures. That was very useful. Less work for me. Okay, if there's nothing else, let's leave it there for today. And like I said, I'll kick out the due dates for labs 5 and 6 just so we can concentrate on them next week during the class session, and we can try and get it done then. Okay, I will leave it there. I'm going to shut down the stream, wherever that got to.